All right, we're going to be factoring and solving polynomials. We've already factored the sum and difference of cubes. Now we're going to be factoring other polynomials. All right, so look at number 10 from your notes. All right, we know going in this thing has a degree of 3, so we're looking for 3 solutions. It's 4 terms, so we're going to factor by grouping. So we're going to group the first 2 terms, and we're going to group the second 2 terms. We're going to factor first, factor completely, and then we're going to solve. All right, so I'm going to pull out the GCF. Pull out a -1. So I'm going to end up with 25x squared minus 1, and x minus 1 is my factors. This is dots, so I'm going to factor again because my goal is to factor completely. It's going to be 5x minus 1, 5x plus 1, and then x minus 1. All right, so if I was factoring, I would stop there, but we're also asked to solve. So I'm going to use the zero product property, set each factor equal to 0. And remember, I know that I'm looking for 3 answers because the degree of my polynomial is 3. All right, so I'm going to get 5x equals to 1, x is equal to 1/5, x is equal to -1/5, and then finally x is equal to 1 are my 3 solutions. So we know this graph is going to touch our x-axis in 3 spots because these are all real numbers. All right, number 11. All right, I see it's a difference. X to the 4th and 36 are both perfect squares, so this would be an example of dots, difference of 2 squares when I factor it. So I'm going to get x squared minus 6 and x squared plus 6. All right, well, 6 is not a perfect square because this possibly could factor again because it's a difference, but since x is not a perfect square, that's as much as I can factor it. I know I'm looking for 4 solutions because the degree of this polynomial is 4. All right, set each factor equal to 0. And let's solve. So x squared is equal to 6. X is going to equal to plus or minus the square root of 6. That's 2 of my answers. And then I'm going to get x squared equals -6. So x is equal to plus or minus the square root of 6. And because it's negative, I got to pull the I out. So those are my 4 solutions. All right, let's put this in standard form first. So I'm going to add the 14x squared. All right, it's a trinomial, so I'm going to use A times C method. I don't have a GCF. All right, so what multiplies to give you 24, but adds to give you 14? Hope you said 12 and 2. All right, let's rewrite that middle term. Now be careful, my middle term is x squared. So I'm going to write this as 12x squared plus 2x squared plus 8. All right, group. Pull out the GCF. Let's do that correctly. Let's pull out a 4. Second one, pull out the GCF. So it factors, common factor, x squared plus 4, and then x squared plus 3x squared plus 2. All right, I can't factor either one of these again. So now I'm going to solve. So I know I'm looking for 4 answers because the degree is 4. So x squared equals -4. X is equal to plus or minus. The square root of 4 is 2, and because it's negative, I get an I. So I've got 2 imaginary solutions. Looks like I'm going to end up with 4 imaginary solutions. So x is equal to plus or minus the square root of 2 over the square root of 3i. And then let's rationalize it. So my other two solutions, I'm going to multiply by the square root of 3. It's the square root of 6 over 3i. So all of these are imaginary solutions. So it's not going to touch the x-axis at all. All right, look at number 13. It's a trinomial, but I see I have a GCF of 2x squared. Let's pull that out first. I get x to the 4th plus 2x squared minus 15. All right, so that's going to be part of my factor, so I'm just going to bring that down. All right, let's factor what's left. That's a trinomial, so A times C method. So what multiplies to give me 15, but has a difference of 2, positive 2, so what, 5 and negative 3. All right, since my lead coefficient is 1, I can go directly to my factors. So I'm going to have what, x squared plus 5, x squared minus 3. So there it is, completely factored. All right. So how many solutions? My degree is 6, so I'm going to have 6 solutions. All right, so set each of my factors equal to 0. Here I get x equals 0. Well, this is a double root because it was x squared. So when I count that, that one 0 counts twice. It's going to bounce off the x-axis at 0. All right, the rest of them, let's see. This one's going to be imaginary. So x is equal to plus or minus the square root of 5i. And this one is real, but it's irrational. So I get the plus or minus the square root of 3. All right, 14. All right, method. 3 terms, no GCF. It's going to be A times C method. I know I'm looking for 4 solutions. All right, what multiplies to give you negative 20, but has a difference of positive 1? So what, 5 and negative 4. Here again, no leading coefficient, so I can go directly to my factors. You can also factor by grouping. This is a shortcut, hopefully that you recognize now. All right, looking for 4 solutions. Oh, this can factor again. Let's finish factoring. X squared plus 5. This is dots. Difference of 2 squares. So I have x plus 2, x minus 2. All right, 0 product property. And let's solve. I know I'm looking for 4 solutions. Well, these 2 are going to be imaginary. I get negative 2 and positive 2. So it's going to touch the x-axis twice. So my 4 solutions. All right, number 15. I'm going to get in standard form first. So I'm going to subtract the 18x to the 3rd. I've got a GCF of what, 2x to the 3rd. So I'm left with x squared minus 9. I know I'm going to have 5 solutions when I'm done. This factors again, that's dots. So that's x plus 3, x minus 3. All right, so I've got 2x cubed equals 0. Each factor equal to 0. X cubed equals 0. X is equal to 0. This is called a triple root. We got to count that one 3 times. So what it means is when it comes through the x-axis, it's going to give you that cubic pattern. Then it's going to turn around and hit at 3 and at negative 3. So which sketch of your graph is going to look like. Okay, but that has to toward our 5. That counts 3 times. So my other 2 solutions are negative 3 and positive 3. All right, let's look at one more example. All right, we're asked to find all the solutions here. So we must factor to do this. If we just try to isolate the x cubed, we're only going to find the one real solution. So let's factor this. All right, this is a sum of cubes. So my first term is equal to x, and my second term is 3. The cube root of 27 is 3. It's a sum. So I get x plus 3, and then my pattern. Square it, opposite multiply, and square the last term. All right, this is not going to factor again. We're going to have to use the quadratic formula or completing the square. Your choice on that. I'm going to do completing the square. All right, so one of my solutions, I know my real solution, if I set this equal to 0, I'm going to get negative 3. I'm going to get one real solution and 2 imaginary. All right, let's complete the square with this. So I'm going to isolate. So I'm going to move the 9. Find c. I have no lead coefficient, so I can go ahead and find c. Half of b squared. And I'm going to add that to both sides. So negative 3 halves squared is going to be 9/4. Factor. Add my terms. So I get negative 27 over 4. Square root both sides. So I get plus or minus the square root of 27. The square root of 4 is 2, and because I have a negative, I have an I. And then finally solve for x. So we've got 3 halves plus or minus. All right, I'm going to simplify 27. What, 9 times 3? So I get 3 square root of 3 over 2i. So I have two real solutions. I'm sorry, two imaginary solutions. The sum and the difference. They're conjugates. And then one's real solution.